distributed denial of service attack, or DDoS attack, is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. DDoS attacks achieve effectiveness by utilizing multiple compromised computer systems as sources of attack traffic. Exploited machines can include computers and other networked resources, such as Internet of Things devices. To think of it another way, a DDoS attack is like an unexpected traffic jam, clogging up the highway, preventing regular traffic from arriving to its destination. DDoS attacks are carried out with networks of internet-connected machines. These networks consist of computers and other devices which have been infected with malware, allowing them to be controlled remotely by an attacker. These individual devices are referred to as bots or zombies, and a group of bots is called a botnet. Once a botnet has been established, the attacker is able to direct an attack by sending remote instructions to each bot. When a victim server or network is targeted by the botnet, each bot sends requests to the target's IP address, potentially causing the server or network to become overwhelmed, resulting in a denial of service to normal traffic. Because each bot is a legitimate internet device, separating the attack from normal traffic can be difficult. The most obvious symptom of a DDoS attack is a site or service suddenly becoming slow or unavailable. But since a number of causes, such as a legitimate spike in traffic, can create similar performance issues, further investigation is usually required. Traffic analytics tools can help you spot some of these telltale signs of a DDoS attack, such as suspicious amounts of traffic originating from a single IP address or IP range, a flood of traffic from users who share a single behavioral profile, such as device type, geolocation, or web browser version, an unexpected surge in requests to a single page or endpoint, or odd traffic patterns such as spikes at odd hours of the day or patterns that appear to be unnatural, such as a spike every 10 minutes. There are other, more specific signs of DDoS attacks that can vary depending on the type of attack. Different types of DDoS attacks target varying components of a network connection. In order to understand how different DDoS attacks work, it is necessary to know how a network connection is made. A network connection on the internet is composed of many different components or layers. Like building a house from the ground up, each layer in the model has a different purpose. The OSI model is a conceptual framework used to describe network connectivity in 7 distinct layers. While nearly all DDoS attacks involve overwhelming a target device or network with traffic, attacks can be divided into 3 categories. An attacker may use one or more different attack vectors or cycle attack vectors in response to countermeasures taken by the target. Sometimes referred to as a Layer 7 DDoS attack, in reference to the 7th layer or application layer of the OSI model, the goal of these attacks is to exhaust the target's resources to create a denial of service. The attacks target the layer where web pages are generated on the server and delivered in response to HTTP requests. A single HTTP request is computationally cheap to execute on the client side, but it can be expensive for the target server to respond to, as the server often loads multiple files and runs database queries in order to create a web page. Layer 7 attacks are difficult to defend against, since it can be hard to differentiate malicious traffic from legitimate traffic. This attack is similar to pressing refresh in a web browser over and over on many different computers at once. Large numbers of HTTP requests flood the server, resulting in denial of service. This type of attack ranges from simple to complex. Simpler implementations may access one URL with the same range of attacking IP addresses. Complex versions may use a large number of attacking IP addresses and target random URLs using random refers and user agents. The key concern in mitigating a DDoS attack is differentiating between attack traffic and normal traffic. For example, if a product release has a company's website swamped with eager customers, cutting off all traffic is a mistake. If that company suddenly has a surge in traffic from known attackers, efforts to alleviate an attack are probably necessary. The difficulty lies in telling the real customers apart from the attack traffic. In the modern internet, DDoS traffic comes in many forms. The traffic can vary in design from unspoofed single-source attacks to complex multi-vector attacks. A multi-vector DDoS attack uses multiple attack pathways in order to overwhelm a target in different ways, potentially distracting mitigating efforts on any one trajectory. An attack that targets multiple layers of the protocol stack at the same time, such as a DNS amplification coupled with an HTTP flood, is an example of a multi-vector DDoS. Mitigating a multi-vector DDoS attack requires a variety of strategies in order to counter different trajectories. Generally speaking, the more complex the attack, the more likely it is that the attack traffic will be difficult to separate from normal traffic. The goal of the attacker is to blend in as much as possible, making mitigation efforts as inefficient as possible. Mitigation attempts that involve dropping or limiting traffic may throw good traffic out with the bad. In order to overcome a complex attempt at disruption, a layered solution will give the greatest benefit. Limiting the number of requests a server will accept over a certain time window is also a way of mitigating denial of service attacks. While rate limiting is useful in slowing web scrapers from stealing content and for mitigating brute force login attempts, it alone will likely be insufficient to handle a complex DDoS attack efficiently. Nevertheless, rate limiting is a useful component in an effective DDoS mitigation strategy. There are many other ways to protect your company or network from a DDoS attack, which are beyond the scope of this video. If you want to learn more, please reach out to us at www.chelseacybersecurity.com. Thanks for watching.